In this video, we will show you how to simulate TA cloning on Mendelgen. TA cloning is a simple cloning technique that relies on base pairing between T overhangs on a linearized backbone and A overhangs on a linearized insert. Now, there are many pre-constructed TA cloning vectors with 3' T overhangs that can be purchased and used as the backbone. The insert can then be constructed by doing PCR on your gene of interest. Certain DNA polymerases, such as Taq, leave a single 3' overhang on the PCR product. Then, after mixing the products with a ligase, through hybridization and ligation, the backbone and the insert will join to make the final cloning vector. Now, let's switch over to Mendelgen and show how we can simulate TA cloning. In the first step to simulate TA cloning on Mendelgen, we need to select our backbone from our library. And below we have all the vectors listed from our library. I have a pre-constructed vector that already contains the 3' T overhangs called p-target. So I'm going to select that one by clicking on it. This will then open the Mendelgen editor with the p-target vector shown in the left. By default it's in a circular map, but this one happens to be linear, so I'm going to switch it to the linear map by clicking here. And then on the right it's shown in a sequence map. Now before we get into actually simulating TA cloning, I want to show you what I would like to accomplish. We have a linearized backbone that has the 3' T overhangs, and now we need to construct a linearized insert fragment with the 3' A overhangs. Now I already have an insert vector chosen that I want to use to make this insert fragment, so I'm going to switch and show you that one. So I would like to use the vector PMD2 to create my insert fragment. Specifically, I just want to use the gene VSVG in my insert fragment, and so we'll have an insert fragment that has just the VSVG gene with the 3' A overhangs, and then we'll take that linearized insert fragment and the linearized backbone that we have the p-target, and then through the TA cloning simulation it will create a circular vector that contains both. So now let me switch back, and then we're going to go ahead and begin the simulation. To start the cloning simulation, I'm going to click on the cloning icon shown here in the menu. When I click on that, it'll give you a drop-down listing all the different cloning techniques supported in Mendelgen. So I'm going to click on TA cloning. Now this opens a cloning tab to the right with a panel below that shows you all the steps that need to be completed before the cloning simulation can run. Now the first step has already been completed because our backbone is simply the vector that we've picked in this editor. Now the next step, orchestrate T overhangs, is only applicable if the backbone that you're using isn't already linearized and contains the 3' T overhangs. Now our example does, so I don't need to do anything. However, let me go through the steps to show you how to do this in case you've used a circular vector as your backbone. So the first step, uncheck the box the backbone has the 3' T overhangs, which will then give you a drop-down showing restriction enzymes. Now you can use these restriction enzymes to cut your circular backbone into a linearized backbone. Then to have the 3' T overhangs, you can either use restriction enzymes that leave a 3' T overhang, or you can use restriction enzymes that leave blunt ends and then add the 3' T overhang. Now, as I've said in my example, we don't need to do this, so I'm going to check the box the backbone has the 3' T overhangs, and move on to the second step where we will construct the insert fragment. So in the first step, we need to select the vector that we want to use to create the insert fragment. As I'd already said before, I want to use the vector PMD2. So I'm going to click that. So in the next step, then we're given the option, does the insert sequence already contain the 3' A overhangs? Now say the vector that you have chosen for your insert is already linearized and contains the A overhangs, then you can leave this box checked and just move on to create insert. However, as I've said before, the vector I've chosen is circular and we need to add some steps to make the insert fragment. So I'm going to uncheck the box. Then after this step, we go on to configure the insert further. So I'm going to choose the feature within the insert vector that's specifically the part I want to use for the insert fragment. So here we click on under feature and we'll get a list of all the features shown in the vector. As I said before, I want to use the gene VSVG, so I'll click that one. And then we're given the option to add surrounding base pairs. This would be base pairs on the insert vector PMD2 surrounding the gene VSVG. Now I don't want to include any surrounding base pairs, so I'm going to leave it as 0. Then to finally create the insert fragment, I just say create insert. This is then given a label and shown below insert created. So now we've completed all the steps to construct our insert fragment and our backbone for our cloning simulation. So all that's left is to click on clone. Great. So now our cloning simulation has taken place and our cloning vector that has resulted is shown to the left. Okay, so it is now a circular map, so I'm going to switch over to circular map and let's make sure everything is completed. So we have the entire sequence that was in the backbone in P target, and then also right here we have the VSVG gene shown for our insert fragment, and they're all together in a circular vector. This completes our TA cloning simulation on Mendelgen. Please check our other videos to see simulations on other cloning techniques.